Hi class, today's lesson is lesson 3-9. It's the last lesson of this unit, and it's on solve decimal equation. Let's go ahead and take a look at the purpose. The purpose today is to solve equations algebraically with decimals. This is going to be a rather simple lesson, I think, for you, now that you know how to do all the operations with decimals. There's no vocabulary today. Let's go straight to the examples because they're very familiar to us. In fact, we only did it in the last chapter, chapter 2 or unit 2. We looked at solving problems algebraically. This time, they just added a decimal, and that's all. Here it says solve each equation and check your answer. Now, as you recall, when we solved equations, you do not have to do this, but some of you like to use this to help you out. It's like a balance equation here. We have g minus 3 1/10 equals 4 5/10. Now, in order to isolate the variable, to get g all by itself, drop down here, we need to get rid of the minus 3 1/10. How do we do that? We do the inverse operation. The inverse operation is adding 3 1/10. That takes away the minus 3 1/10, leaves us with the g. What we do to one side, like on a balance, we do to the other side. We have 4 5/10 plus 3 1/10. Now I'm going to transfer this down here so I can add that better. All right. So here I go. I'm going to add, make sure the decimals are lined up. 5 and 1 is 6. Decimal point goes down. 4 and 3 is 7. 7 and 6/10. Next, we have the same type of problem that we need to solve algebraically. Here we have 3 times k equals 8 1/10, or 3k equals 8 1/10. How do we isolate the variable? Well, we have to divide. And what I'm going to do here is I'm just going to write a fraction bar because a fraction bar indicates division. I'm going to divide by 3 in order to get rid of the times 3. The k drops down, and what we do to one side of the equation we have to do to the other side. 3 goes into 8 1/10 how many times? Well, I'm going to work off to the side or below in this case. Divide by 3. 3 goes into 8 2 times, but before I actually do that calculation, I should put that decimal point right in the quotient, right above the other decimal point. 3 goes into 8 twice. 3 times 2 is 6. I subtract 6 from 8. I bring down the 1. 3 goes into 21 7 times. Subtract 21, I have no remainder. It's 2 and 7/10. Finally, I've got another example here. We have m divided by 5 equals 1 5/10. In order to isolate the variable here, I need to find the inverse operation of division of 5. Well, the inverse operation of dividing by 5 is multiplying by 5. So I'm going to multiply by 5 here, which drops down that m. And then I'm going to multiply by 5 over here. When I multiply by 5 over here, that doesn't look like a 5 though, does it? I'm going to, off to the side, I'm going to go ahead and show my work. Now I'm going to treat them as if they were whole numbers, so I'm going to treat this as if it was a 15 times a 5. I don't need to line up decimal points when I multiply. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 75. Now I go back to the problem and I count decimals, place values. Place values to the right of the decimal point. Here I have 1, and below here I have none. So I move the decimal point only one position to the left. So my answer is 7 5/10. I put it here. 7 5/10 is equivalent to m. Now for each of these, I should also go ahead and check. So I'm going to choose another color here because it does say check your answer. I'm going to take, in this first case, the 7 6/10, and I'm going to subtract 3 1/10. Line up the decimals, make sure that's there. 6 subtract 1 is 5. 7 subtract 3 is 4. 4 5/10 shows up. Now I look at this problem as well. I'm going to go ahead and take 3 times k, which we see as 2 7/10. And I'm going to treat it as if it was a whole number. When I multiply this, 7 times 3 is 21. 2 times 3 is 6 plus 2 is 81. I move the decimal place over 1 because there's one place value to the right of the decimal total in the factors. So 8 1/10, or I'm sorry, I should say 2 7/10 is a solution for that particular problem. And finally, I'm going to take 7 5/10, my answer here, divided by 5, as I have in the original equation. I should come up with 1 5/10. I place that decimal point right there above the other decimal. I multiply. How many times does 5 go into 7? Well, it goes in once. 7 subtract 5 is 2. I drop down the 5. 5 goes into 25 5 times. I have 1 5/10, and that checks out with what I have above. All right, let's take a look at a final example. The final example is a word problem. Here we're looking for the area of the floor in Jonah's bedroom to be 28 square meters. So I'm going to write this down as 28 square meters. And the length is 3.5 meters. So the length from here to here is 3.5. What's the width? So they're asking, what is the width of this particular bedroom? We're going to go ahead and establish an equation with that, which would be 28 meters squared being the area, and 3 5/10 being the length. We know that area equals length times width. In fact, we know that if we substitute those numbers, 28 equals 3 5/10 times the width. When we divide that out, or I should say, well, I'm jumping ahead, when we solve this equation, we need to find the inverse operation of multiplication. Why? Because we want to isolate the W all by itself. In order to do that, we need to divide by 3 5/10. When we divide by 3 5/10, that W drops straight down. How many times does 3 5/10 go into 28? This is where things can get a little messy. So here we have a whole number divided by a decimal. We know in the divisor we can't have a decimal, so we're going to move that over one place value. So now it's 35 divided into, well, if I move the decimal point once in the divisor, I need to do so in the dividend. So I move it once over. I have 35 into 280. Now, how many times does 35 go into 280? Well, I know 35 times 10 is 350, so half of that is, well, it's going to be less than 280. So I'm going to look for numbers that are generally going to get me close to 280 here. So let's give it a go. Let's try 6. If I try 6, I get 6 times 5 is 30. Great, I got a 0 there. That's a good start. 6 times 3 is 18 plus 3 is 21, and that's not going to get me there close enough. So let's try another number. Let's try 8 this time. 8 times 5 is 40. 8 times 3 is 24, plus 4 is 28. 280, subtract 280, 0. So there's my answer, actually, without the label yet. 8 meters is the width of that bedroom. Now we go to complete the problem. We've got 3 problems that I want you to go ahead and copy down and solve. And we'll see you in class.